Okay, the dimensions of a piece of paper, A4, to the nearest is 21 times 30 centimeters. It is possible to create an open top box by cutting 4 squares and folding up the remaining flaps. So this is a classic problem. Let me show you here. So you take a piece of paper like this, and you can cut a square. You cut the same square in each of the 4 corners, like this one. Like that, it makes an open top box. So I'm just going to roughly do it. Put those squares out, something like that. I can fold these up, fold this up, fold this one up. And it makes a box like that. So you get a rectangle like this one, and we cut out squares here. This is X, this is X, this is X. This is X, this is X, all the way around. That would be the base here in the center, that little rectangle on the base. These are the sides. Calculate the volume of the box. So we need to calculate the volume of this box. So we need to first find the length of this side here. What is going to be the length of this side here? If this side here is 30, and this side here is 21, what will be the length there?
30 minus x.
30 minus?
X. 2x.
So one of the lengths is 30 minus 2x.
Why 2x?
Because there's 2 squares.
What's the length here of this side?
21 minus
21 minus 2x. So our cube, we're going to make a cuboid like this one. Looking like that. This length here is 30 minus 2x. This length here is 21 minus 2x. How about this length here? How much is that? Discuss with the person next to you. How big is that?
Oh, is it just x? Because
Discuss with the person next to you, giving more people the opportunity to answer the question than one person shouting it out.
It's a shower.
Okay, let me say the register well. We discussed that.
What do you think?
Okay, so how high is it in this direction?
X.
X. This is going to be X.
Wow.
So now we have the volume in terms of X of the box. We need to find the maximum volume. How do we do that?
You equal 0 to 0. Oh, find the derivative and then equal it. And then
How do we find the derivative?
you expand the brackets.
So let's do it a bit at a time. You can use your calculator for this one. $630 or so.
630.
630. Let's do this one. Can you use your calculator?
Negative 6.
negative 60x. Let's do this one.
So that's
The minus 42x one. Minus 42x. Oops. And then lastly,
Plus 1.
this one.
Plus 4 squared.
Plus 4x squared. Okay, let's expand this bracket. It's quite easy. We add an extra x to everything. And then these two middle terms, we add them together.
why do you add extra x?
So we've got this x here at the end, because it's three-dimensional. At the moment, that formula inside that long bracket is the area of the base. That's the area of the base. To make it into a volume, we times everything by x to create the height. So it's going to give us 630x minus 102x squared plus 4x cubed. Is that correct?
Yes. Yes.
Yeah, we got one yes so far. Anybody else? Are we right? I feel we're right as well. It's not a trick question. I'm just having you guys check my arithmetic. So we found a formula. So the first step is find the formula. Next step, find the constraint formulas, and then create the formula in terms of one variable. What's the next step?
To make it, because
Find the derivative. Find the derivative. So v dash of x. What is the derivative here?
1 second. 630
630.
Let's have Mar here this time. Go on, Mar here. 630 minus
204x
204x
plus 12x squared.
plus 12x squared. Okay. What's our next step?
equals
Why do we set it equal to 0?
because that's the rate of dimension at the max.
Why do we set it equal to 0?
Because when the derivative is
Maxima and minima occur when the derivative is equal to 0. So
So we have to find the value for x that's negative 0. Yes.
let f dash of x equal 0 to find extreme points. So maxima and minima are types of extreme point. We use maxima and minima as the plural of maximum and minimum. We don't say maximums. So we need to solve this. So calculator for this one. If I rearrange that, I get 12x squared minus 204x plus 630. For this one on your calculator, use menu 331 on the calculator. Use menu, do it now.
On the back.
Menu 331, polynomial root solver.
Because it has more than one variable.
No, because it will have more than one solution. It only has one variable. It's a polynomial. So we use the polynomial root solver.
Wait, what's the last one?
Menu 331. Oh, it's different on yours. Polynomial root solver. The polynomial. So go to algebra. Polynomial tools. Find the roots of the polynomial. So
This?
the first one.
4.0559.
Who would like to give me the first one? To 3SF. Mila.
4.06.
Yay!
Is it really 0.56?
You see?
So I'm the one wrong.
I got.
Oh wait, we counted the first one too. Oh.
Okay. What is the second root?
12.9.
12.9.
Yeah, 12. artificially better than perfect.
How do you know when it has two solutions? Like one with
Polynomial.
No, like,
yeah.
So we recognize a polynomial because you've got only x is in. Sorry, it's got just one variable, firstly, x's, which it should be anyway. But the x's are raised to whole number powers. So positive integer powers.
Also, we're just explaining the derivative.
So where the exponents have to be positive integers. If you've got a reciprocal, you've got x in the denominator, no. If you've got an exponential expression like e to the x or 5 to the x, no. So if the expression looks funny, it's not a polynomial.
what about the one before that was very
Also polynomial. Also polynomial.
But n solve just wants to find one variable for the first one.
N solve will only let me find the closest one to 0. So it's useful to keep sketching through until you find no more solutions, or graph it to get an idea of how many solutions there's going to be.
But I use n solve just about
N solve is fine on that last one because there is only one solution. So the number of solutions for a polynomial comes from the highest order exponent.
Okay.
So the highest, this is the degree of the polynomial. So this is a second degree, and a second degree polynomial can have up to two solutions. It won't have, it won't always have two. It could have none, it can have one, and it can have two. But it would have up to and including two solutions. That previous question was a linear polynomial, so first degree. The power here is 1. So this one can have up to and including one solution. That, in fact, no, they always have one solution. You can't not have a solution on that one. All right, so what are we up to? We are calculating the maximum volume of the box. So we need to decide which one of these is going to give us the maximum, which one is going to give us the minimum. At this point, you've got a few choices of how you could do it. You can, so this question is not so great, well structured for this course. I think the easiest way would be to sketch this. And find the maximum volume of the box. But usually they structure it in another way where you have to use the derivative to do it. So to use the derivative to do it, you want to sketch the derivative. So I'm going to ask you now to sketch the derivative, which would be this function here. We've got 12x squared minus 204x plus 630. Looks like that. So we need to change the window settings. We already know the solutions, 4 and 13. So there's 4, 13 is over here. So when we change the window settings, here on the window settings, we don't need the negative values because x can't be negative, it's a length. X can't be negative, it's a length. And we need to go over 13, so let's go up to 50. Now you've got a 630 there, so when x equals 0, the answer is going to be 630. So we should include quite large values. Let's go minus 200, and then up to 700 or so. There we go. We get an idea of the picture. So what we're looking at here, our graph looks like this. Which one of those is a maximum? Which one is a minimum?
13, because it's positive and 0.
Here's positive 0 negative. Here's negative 0 positive. Which one is a maximum?
4.
4. 4 is a maximum. It goes positive, 0, negative. That means the original function goes up, 0 and down. And this one, it goes down, across, and up. That one's a minimum. So this question is not structured to force you to do that, but we need to calculate the maximum volume of the box. We know it occurs here. We have a function there. So we need to find V of 4.06. So let's have a little look. We can put that into the function. 630, 4.06 minus 102, 4.06 squared plus 4 bracket 4.06 cubed. Put that into your calculator. What do we get?
Why do you multiply 630 by 4?
Now this is a good question. Sabina asks, why am I multiplying 630 by 4? Now a common mistake on this one is to confuse these two equations. This one tells you the volume.
And the other one's
The other one tells you the rate at which the volume is changing. So this is a really, really, really common mistake. Is which one do I put the value into? Are you trying to find the rate at which the function is changing? Or are you trying to find the rate at which the function is changing would be 0. But you're trying to find the volume. So make sure you put it back into the correct equation.
So you plug it back into the equation, like the maximum of that you find.
What do you get?
1,144.2.
3 significant figures, please.
Right?
3 significant figures? Anyone?
So if it's a 3-digit number, we still include one decimal, right?
3 significant figures?
I'll just fix it 0. Why? It's all.
Oh, so we don't include this.
Sir, our tutor is also mad at you because you graph F prime. She says you're messing with our heads.
That's because when the question's going to come at you, it's going to come at you like that.
Yeah, but she says it's too advanced. Like, we can't comprehend it.
Yeah, but
Even Math AA doesn't graph F prime. It's only used.
no, it's going to come at you that way. So there's a good chance you're going to get given a graph of F prime and asked to say where's the maximum.
But that's always that 0 with the tangent.
It's like below that.
Yeah, no. So you get a graph of F prime, and let's say you have 2 plots places where it's 0.
Okay,
You've
so
got-
then we do the
You've got to
positive.
identify which one it is, and that's the question I'm training for.
Okay.
So tell her
We
that.
have a major. She still doesn't go to people.
Do we have a major as well?
She's.
Majors as well.
Do we have a major as well?
Yes.
F prime?
So where are we up to? Find the dimensions of the open top box that can be
Oh,
Uh,
it's not like-
created.
Yeah, I think I just-
So we haven't quite answered the question yet. Look at B. What do we need to do here for B? We've got that. That was A.
This is always A.
That was A.
This is A.
So we need to find the dimension.
This would be a 15-point question broken down into multiple parts, forcing that the graphing of this and the determining of that.
We're not having this equation, right?
Yeah.
This.
It's an 8-point question on the page
Oh, it's-
with 4 subparts. With 4 subparts.
Something different, but it's like this.
There's only one though, yeah?
Points.
Only one
I
or
really
one?
like this.
Oh, no.
First one.
I like this way better.
Okay. Let's have a look at B. Find the dimensions of the open top box. So we've got 4.06 as X. What does that mean the dimensions are?
4.06 and
No? Oh yeah, there is. That's one of them. So B. 4.06 by what's the other dimension? Use these.
12.9.
Is it?
Like
600.
So what's 30 minus 2 times 4.06?
What? What do you have?
We've got 30
Oh.
minus 2 lots of
Okay,
x.
Right, so we put that in.
So 21.9. And then
Oh.
read the question carefully. Make sure you answer what it asks. 12.9. Okay, that finishes that question.